welcome back to geometry. We are looking at lesson 67. It's page 445 in your textbook, so please open your books to lesson 67 and we will begin. Introduction to transformations. I wish we were together here talking about transformations because we'll talk about them more later, but simply put, we're thinking about shapes. And we're going to think about shapes and changing their position, their size, their orientation, however. So we're going to change them in some way. That's the transformation that we're talking about. So in the book, a change in position, size, or shape of a figure is called a transformation. And then there's different types of transformations. And we'll look at some of them, like translation. That is simply taking something and moving it this way for the sake of geometry. It is not like you're translating a book. But translation, reflection, rotation, and those are all types of transformations. A couple more terms. When you do a transformation, you have an original figure and then you apply the transformation to it. What you get is two images then. You would get the what they call the pre-image, which is what you had to begin with, the pre-image, and then when you're done with the transformation, that is called the image. Seems a little bit backwards. We would like to call the original the image and the new one the post-image, but we're saying pre-image and image. The original before the transformation happened is called the pre-image. So I have these, let's just do one. I have no, let's not do that. Let's do a figure like this. Here's a rectangle like this. Here is an image. It's A, B, C, and D. It's rectangle A, B, C, D. And I apply a rotation to that image, and I place it over here. And let's say I'm going to rotate this image 90 degrees. So now my new image is like this, and technically you need to follow the vertices over. Now I'll allow you to leave the numbers up, or the letters, and not write them like this, because that's really how it would look. But we'll write them the right way. So A, B, C, and D. We just took this and rotated it 90 degrees. Hope you can see that. That is now a transformation. That's a rotation. That's the type of transformation. And this is the image, and this is the pre-image. And technically, you're supposed to put little marks up here. We'll get to those in a bit. Image image and pre-image. Pre-image is before. All right, transformations. Here's a new word, isometry. An isometry is a transformation that does not change the size or shape of a figure. That is, the original image and the pre-image are congruent to each other. That is an isometry. So there's different types of isometries. You can have a translation, where you just move something. You can have a rotation, like we did here. You can have a reflection, where it actually would reflect across, and you can also call that a flip, but it would turn like this. Let's do it this way. Let's reflect this rectangle across here, and we draw a reflection line. So every point on this line gets reflected across here, and then we have a new one over here. The only change is that A is over here and B is here. See how it flips? Because B was further away from the line, so B needs to, same way over here, B needs to be further away from the line. It's just taking this image and flipping it like this. So the order changes. D is over here, and so if you're looking at clockwise rotation, you would first say A, B, C, D. Here all of a sudden it becomes A, D, C, B because you're flipping. When you flip or reflect, the order of the vertices changes. Again, a reflection or a rotation, those are both considered, those are both types of isometries. Again, I forgot to put the prime marks. These are called prime marks. They should be in there as well. All right, so an isometry maps a figure to a congruent figure. That is, if I want to do an isometry, if I apply an isometry, again, that's just a type of transformation. Then you know that the original image, the image and the pre-image are going to be congruent to each other. And you always label, the vertices are the same label, except you put a little tick mark above it, and that is a prime. It's called a prime, so it's like A prime, B prime, C prime, and D prime. And that is your cue that a transformation happened of some sort, and then you'll figure out what type of transformation. All right, keep going. We're in the middle of page 445. An isometry is also called a congruence transformation or a rigid transformation, and that makes sense. Congruence transformation, the transformation happened and the two images are congruent, or they happened in the rigid. Nothing happened to the size of it or the shape of it in any form. It just moved its direction, its orientation, or whatever. So a reflection or a flip is what we did over here. It's also in the bottom of an example, kind of a funny round figure on the bottom, page 445. Reflection or a flip. We skipped a translation. A translation or a slide is simply taking this and moving it. So we could bring our friend vectors back to play and say, let's apply a vector of 10 inches and whatever, 45 degrees to this rectangle. So you can imagine this vector in here, and it doesn't matter where we put the vector, it's simply oriented the right way we want to go and 5 inches long. And everything here is going to go 5 inches this direction. So you end up here, same same vertices, same orientation. Nothing really happened except it just slid. That's why they call it a slide. It can be a slide or a translation. Just going that way. All right, you'll catch these terms as we use them. Turn to page 446. Rotation or a turn. We did that already. This one is a picture of a polygon of some sort, and it was turned or rotated about one of the points. So like this stayed anchored. That's the rotation point, and then the whole thing just pivoted from there. Identifying types of transformations. Example 1, identify the type of transformation illustrated below. You look carefully at it. It looks like it was reflected on a vertical line, and you'll notice it says V and V prime, and they're right together. That is technically how you would do it. So, for example, here's my rectangle again, and now instead of rotating on a line over here, or flipping it on a line over here, I'm going to flip it or reflect it on this line right here, and flip it across. Well, if I flip it across, it happens here, and this A should really come over here. On this side, the point is A. The vertex is A over here. For this image, it's A prime. Even though it didn't move, it's still pointing to that same vertex. It didn't move, but technically there's two vertexes on top of each other, two vertices on top of each other, C prime and B prime. So you can reflect it on a line. That's part of the figure. That's why there's a Z and a Z prime and a V and a V prime listed right together. So that's a reflection or a flip. Look at B, and again you have to look carefully sometimes to see is it a rotation, is it a slide or whatever. But if you look at the triangle, that is example 1B, that looks like a rotation to the left, rotation like that. Letter C, that's simply a slide or a translation. Now, example 2, you'll perform transformations. You won't do it in the book, but you get the picture. You will do it on your homework, and you'll draw them out. You can maybe lay the paper on top of your book and trace it, and then perform the indicated transformation. So again, a couple words, starting at the top. In general, transformation. Transformation is taking a shape and changing it. And then there's different types of transformations. We talked about a translation. A translation is sliding it this way, a translation or a slide, a reflection or a flip, and then a rotation. All three of those, a translation, a reflection, and a rotation, those are all examples of isometries. That's the type of transformation. It's an isometry, and that means it did not change the size of the shape. It just moved in some direction or changed its orientation or whatever. Isometry. Iso is means equal, and metry is measure, so equal measure, isometry. Kind of like isosceles triangle. That is the end of lesson 67. I'm going to go ahead and write the homework down for lesson 67 now so that you can do it, and then we will look at lesson 68 next. All right, homework for lesson 67. Again, this homework and lesson 68 both will be due Monday, 9 o'clock. Hopefully we'll find another way to score homework. All right, homework for lesson 67 is 1, 3, 5, 6, 8, 14, 15, 16, 22, 23, and 9. I hope you can read all those. 1, 3, 5, 6, 8, 14, 15, 16, 22, 23, 29. Thank you.